And good afternoon, everyone. Thanks for joining us. My name is Zach Allison with ATS, and I'm sure most of you have been here before, so you're probably familiar with my spiel, but I am our ATS Market Development Manager. I work with engineers all across Canada and the United States, helping their firms get set up on the ATS spec tool. If this is your first time attending, thanks for joining us. This is our ATS University series, where we deep dive one of the many manufacturers that are available for configuration on the spec tool. And if it's your first time joining us, then the ATS spec tool is a product selection or a product configuration system. Lives online, free for all engineers, designers, interior designers, architects, design build contractors, anyone looking to make product selections for any of the products that we have on the system. It is live updated with manufacturer's information. We have relationships directly with the manufacturers to make sure that we're always giving you current information. It's a great way to help keep your masters up to date. So if you're looking to learn more about that, feel free to reach out to me afterwards. That's kind of my team's specialty, getting firms set up with their masters on the spec tool and then helping your team learn how to take those masters into their day-to-day work. So that's the kind of short spiel on ATS and how we try to provide these free solutions for the design community. The other part that we try to offer the design community is continuing education. And that's why we have our ATS University and all of our manufacturers that provide these, detailed lunch and learns, detailed webinars for everyone. This is an ASPE accredited webinar. So we'll take the list, send it over to our colleagues after, and they'll get the certification sent out to you. And we also have our ATS certificates of attendance. So if you don't need the accredited version, you'll have that from us shortly as well. And you can send that in for your CPD hours or anything like that. I'm going to be mostly just kind of monitoring the chat, piping in questions. So if you have questions along the way, pop them into the Q&A field. I'll raise them as we kind of get to an appropriate part in the presentation, which leads me today to our wonderful colleague, Brian, Director of Codes and Standards and everything technical you could possibly have in relation to cast iron pipe. He's been a tremendous resource for me as we've had this product for, I guess, coming up on a year on the spec tool, and there's been a lot of detailed questions when it comes to codes and standards and updating various firms' masters to include Charlotte Pipe and make sure that they have a standards-based master with the appropriate guidance on manufacturers as well. At the end of the presentation today, I'll show you how you can find some of the products that we're talking about directly on the spec tool. It's super easy to use, super friendly to configure and make your selection, and also show you how quick and easy it is once you have your masters on the spec tool to just drag and drop into your everyday projects. So with all that being said, I'll pass it over to you, Brian. Thanks for joining us again.
All right, great. Thanks, Zach. Good afternoon, everyone. Thank you for joining us. My name is, as Zach said, Brian Connor. I work with Charlotte Pipe and Foundry. And for those of you who do not know, Charlotte Pipe is a 125-year-old fifth generation family owned company headquartered in Charlotte, North Carolina. We operate one foundry where we make cast iron pipe and fittings, and we operate 7 plastics plants where we make ABS, PVC, and CPVC pipe and fittings for many different applications. Today, however, we're going to be talking about cast iron and in particular aggressive DWV applications and specialty coatings that go along with those. So I assume since you've tuned in, that's something that you might be interested in. I'm going to go ahead and share my screen, pull up the presentation, and we'll get started so that we're conscious about your day. Let's see here. All right, I just did this a second ago. And so you will receive CEUs if that's something that you're interested in. If it's not something you're interested in, you'll still receive them. So before we get started, we really probably should do a bit of a history lesson. We won't go all the way back, but maybe back to the time where our folks became civilized. Of course, as population grew, it became necessary, and folks realized it, to divert water from its natural course to provide drinking water, bathing, sanitation, cooking, cleaning, all sorts of things. And history would tell most of us at some time or another that the Romans and their aqueducts were some of the first civilizations to divert water for these causes. And you see pictures like this one of the aqueducts that the Romans actually constructed, and you think, oh, that was those guys were ahead of their time. And while they were not the first. There were other civilizations thousands of years before the Romans came to power that were doing things similar to what we're doing today. They were constructing pipes using materials like clay, lead, bronze, wood, and other things. There's evidence of cisterns on the island of Crete that date back 4,000 years. The Egyptians actually had water piped into some of the pyramids in copper pipes or tubes. So it's really interesting to see. But of course, this is great brand advertisement that the aqueducts are still standing. As a matter of fact, back in the day, engineers who had engineered things like these aqueducts had to stand underneath it as the scaffolding and other supports were removed to prove their prowess as an engineer, and that their systems were going to work. But getting back to sort of the topic at hand, you see a picture here. This is one of my colleagues, Mike Lemaster, holding a piece of wood pipe. Obviously, today nobody's using wood pipe. We know that there are some wood pipes that are still in ground and maybe even still in service, but obviously no one's installing those. And the same could be said for lead and bronze and other clay pipes that they were using hundreds or even thousands of years ago. This wood pipe in particular, you'll see the coil around it. It was there to sort of hold tar in place, which they would pack in to kind of preserve it and make sure that it was watertight. So it's an interesting part of history, but it's from a bygone era. Again, nobody's installing that. Nobody's installing a lot of products that at the time, hundreds or thousands of years ago, were sort of cutting edge. Now, the reason that we're talking about cast iron today is that, unlike some of these other products, cast iron has moved throughout history and has proven itself to be a very durable material. So these others were prone to deterioration or frequent breakdown, and so they've kind of gone by the wayside. But cast iron has quite the history. Here's something that I put in place because I knew everyone would recognize it. It's the Palace of Versailles. And King Louis actually ordered that 15 miles of cast iron pipe be installed to power this fountain. And that was in 1664. The reason that I'm including that is that after more than 360 years, that pipe is still in service. So what a great history lesson for how durable cast iron can be. The actual first recorded use of cast iron that anyone can find predates this by 100 years. 1562 in Germany, also used in a fountain application. So cast iron has been around for a really, really long time. It is a very durable material, and it's got lots of advantages. Now, today, obviously, we're not using cast iron to pipe up any more fountains, and we're not using it for pressure, although only about 100 years ago, folks were still installing the same cast iron into applications to deliver potable water. Hopefully nobody makes that mistake anymore because it's not NSF certified and you have to have that. But today, cast iron is used most commonly in sanitary drain waste and vent applications or for storm drainage. It's used both above grade or below grade, and it can work in applications up to 100 degrees Celsius. Now, these applications are designed and rated for gravity drainage, so they're non-pressure, as opposed to some of the applications that were used hundreds of years ago. Cast iron really is meant to only be tested up to 4.3 psi, which is about 10 foot ahead. Not that the pipe itself or the fittings can't handle more pressure than that, but the joining method is sort of the limiting factor. And we'll talk a little bit about the joining method for what is most commonly considered MJ pipe and fittings in the Canadian market. But getting back to some of the advantages of cast iron, of course, you've already seen a couple of examples of the longevity of cast iron, but cast iron has been used for lots of things over the years, for manhole covers, for decorative grading on the city streets. Armies used it for cannons for hundreds of years. And the Smithsonian, which you guys are probably familiar with, in DC, is one of the first recorded and well-known uses of cast iron soil pipe in the U.S. Originally built in 1881, it has a cast iron DWV system throughout. In 2010, they began a evaluation of the plumbing system, again, all DWV cast iron pipe, and found that the pipe still met the specifications. So 130 years later, cast iron is still working as it was intended when it was installed in the Smithsonian in 1881. So it's pretty impressive. Another one of the advantages that's integral to cast iron is that it is a sustainable material. Domestic cast iron, that being cast iron made in North America, is made from 96% post-consumer recycled scrap iron, and cast iron is 100% recyclable. So every piece of cast iron pipe or fittings that is manufactured in North America is made solely from reconstituted cast iron that was formerly a brake drum or a cast iron tub or some other cast iron, maybe even cast iron soil pipe that was used and the building was demolished. But the other 4%, I'm normally asked about what about the other 4% and the 96% post-consumer. That's going to be your shredded steel and your coke and some other metallurgy that has to be added just for processing, but there's no iron ore, mined iron, that is used in the production of cast iron made in North America. That's not true for offshore. A lot of the Chinese, in particular, do use pig iron. Just because they don't have the scrap to use. So they do mine some iron ore, but domestic manufacturers are using 96% post-consumer recycle for their cast iron today. And the USGBC lead building system and ICC verification reports do provide some proof that what I'm saying is true. If you ever need it, it's available from any of the domestic manufacturers. Now, let's talk just a little bit about the joining method for cast iron. Again, in the Canadian market, your MJ or hubless pipe and fitting system is the predominant system. Manufacturers in the U.S., Charlotte, Tyler Pipe, and ABNI, all manufacture hub and spigot and even extra heavy cast iron pipe. But I've been told that unless it's a historic project, that hub and spigot is not typically used in the Canadian market, that it's almost exclusively MJ. So we're going to focus solely on that today. So your MJ couplings are a neoprene gasket that fits inside of your stainless steel shield. The gasket has a center stop, and you want to make sure that all components hit the center stop that you can see in this photo here. And you want to do that so that you've got a balanced coverage between both pipe and fittings. You may also notice on a fitting, you've got a little lug there. That's the W dimension that's referenced within the standards. It's also called a locator lug. And that locator lug will tell you that your gasket and your coupling have been placed in a position where you've got equal coverage so that it is at the center stop, since you can't see inside the coupling once you're joining the pipe and fittings. Now, once you've done that, you will place the stainless steel shield over top of the neoprene gasket, equally covering the gasket on both sides, and then use the tightening sequence from the manufacturer, depending on whose coupling you're buying. In this example, this is a standard duty coupling. So it's your normal coupling. You'll see it's got two worm gears, and they're tightened down to 60 inch-pounds. So very simple installation method that can be complicated sometimes if you're not using the right tools. These couplings do have recommended torque settings. And so in this photo, you'll see Milwaukee Tool actually makes a no hub torque gun. And I helped them work on this and develop this in 2010. So it's been around for quite some time, but it uses a lithium ion battery that doesn't lose power. It just dies. And the reason that that's important is that you make sure that you get appropriate torque in that tool. However, most folks are using tools like you see here, a standard T-wrench or C-conch torque tool. The important thing here is that for your standard duty coupling, MJ couplings, that they be torqued to 60 inch-pounds. And you'll see it here on the Milwaukee tool. It has two settings, 60 and 80. 80 is the most common torque setting for your heavy duty couplings. A heavy duty coupling is going to have more worm gears on it than your standard duty, and it's going to be a wider coupling. And some of you of engineers may actually specify heavy duty coupling. And it's fine if you do, but the heavy duty couplings are a little bit more complicated, and depending on the manufacturer, their installation instructions will tell you in which direction these couplings should be torqued. And this is critical. And the reason that I mention this is because most of the folks that I see installing these couplings do not follow the recommendations of the manufacturer, but you'll see knurling patterns on these couplings. And of course, this is a line drawing here, but you'll see that this one is a horizontal knurling pattern on this coupling. And then this one's got more of a woven vertical and horizontal pattern here. And through research, they found the best patterns for tightening these. Some of them may be directly left to right, depending on whether there's a smaller outside diameter to the pipe or the fittings. Or you could have recommendations that you would tighten a 3, 4, 2, 5, 1, 6 type of tightening sequence. So it is important, because you will go to job sites from time to time and see this. And in this picture, it's a little bit hard to tell, but there's actually 4 different manufacturers' couplings installed here. And the reason that this happens sometimes is that manufacturers may start a job with whatever's left over from their last job, and it makes sense. We would all do it. The important thing to note here is that each manufacturer identifies their couplings by color. Here you'll see some that are just straight stainless steel. This one has a blue shading on it, and there's one back in the back that has orange here. And for each one of those couplings, they have different tightening sequences. And for heavy duty couplings, the standard doesn't require them to use a set torque. For your standard duty, it's 60 inch-pounds, but for your heavy duty, it could be 80, it could be 120. So it's really critical that the installing contractors know whose couplings they have, what the torque requirements are, and what the tightening sequence is. And what we saw on this job was that they were just using their standard drive motor on a drill to tighten it down. And we're not using torque wrenches on this at all, and they had leaks. So that's the reason we were out on this. They had several leaks, and we found that the reason was that they were not tightening it down to the correct torque or the right sequencing. So it is very important. Now, having covered couplings, let's talk a little bit about the coatings. That's really why we're out here today, right? So your standard cast iron pipe and fittings, the fittings are coated in a cold dip asphalt emulsion. That's 53% asphalt solids and 47% water. Most manufacturers are using this for coatings on their fittings. I work for Charlotte Pipe, and ours are a little different. We have been e-coating our fittings for about 10 years now. So we do not use the cold dip asphalt emulsion. We do e-coat all of our fittings, and it gives our fittings a little better appearance and flow characteristics. And we believe in that. But before that, for 115 years, we used cold dip asphalt emulsion. Now, all manufacturers, including Charlotte Pipe, use a hot dip asphalt. 100% petroleum asphalt is used on the centrifugally cast pipe. And so the pipe is simply dipped into the asphalt or petroleum asphalt. And that's the coating for standard cast iron across all manufacturers. And this has worked really well for a very long time. Standard cast iron, like what we're describing here, has the ability to convey liquids in a really wide range of pH, as low as 4.3 and as high as 10, which covers a good swath of the pH table. Now, as far exceeding what you normally would find in your DWV or storm drainage applications. Those usually range in the 5 to 8 pH range. What's interesting is that over the last maybe 10 years or so, what the industry has seen is that the pH has begun to creep a little wider of that standard 5 to 8 range, and some of it's attributable to COVID actually, and the cleanliness of buildings, particularly hospitals, because of the concern of spreading disease or sickness, but also in the aggressive cleaning chemicals that folks are using and now putting down the drain in conjunction with low flow fixtures. So, with the proliferation of low flow fixtures, it's actually raised the pH range of the fluids that's inside of your system, because what you see is there's less water inside to float the proverbial boat. And any solids that are left behind are, of course, going to they're going to break down, and when they do, they off gas, which rises the pH range in there. Now, when your effluent exceeds the pH limits of standard cast iron, you may want to look at the enhanced coated options that are currently available. And we've seen that over, again, the last 10 or 12 years, there have been a lot of applications where the effluents have become more aggressive to metallic pipes, not just to cast iron. So we'll talk a little bit about that. These enhanced coated cast iron systems now can handle pH ranges from 1 to 13. So many orders of magnitude above and beyond what standard cast iron can handle. Again, as low as 1 and as high as 13, nearly covering the entire pH table. Now, here's a good opportunity for me to slow down for just a second and let you know that while enhanced coated cast iron can handle lots of really aggressive acids and bases, these alkalis that range all the way up to the 13 pH range, there is no standard for these materials to be used for chemical or acid waste. So right now, for chemical or acid waste applications, you've got just a few different piping systems that are commercially available. Polypropylene, PVDF, which is polyvinyl fluoride, and glass pipe have all been around for quite some time. And you also have CPVC for chemical and acid waste. One of the older systems that a lot of folks may have been familiar with is no longer commercially available, and that's high silicon iron. There was only one producer of that, and they went out of business about 6 years ago. So there is no longer the Duriron, and normal iron, even though the enhanced coatings have the ability to handle very aggressive effluents, do not meet a standard that is recognized within the codes for use in acid waste or chemical waste applications. So I just wanted to make sure that we're clear on that. This is purely for DWV applications that have aggressive effluents or some sort of environmental stressor. And we'll talk more about that throughout this presentation.
I'll
Yes.
jump in there real quick. Just the Duriron thing is probably the funniest story to me along the lines. And it's been a terrific feature as we're going out trying to help people update their pipe masters
Okay.
on with our ATS spec tool. Because a lot of the times they're like, oh, why do we need a pipe master update? And I reference that in the fact that I'm there because I found copies of your spec in the market that included a product that is not the manufacturer doesn't even exist anymore. So
Yeah.
it's a tremendous way to help people understand why they need to update their pipe master.
Yeah, it's a great point, Zach. Yeah, it has been at least 6 years, maybe 7 years since there was a high silicon iron commercially available. So thanks for that interjection. So here you see the pH scale. Lots of these things go down the drains every single day. It's not until you get to some of these really aggressive effluents that the code details that you need special waste for that. You know, folks wouldn't think that apple juice or lemon juice or tomato juice can be very aggressive, but they can. And then this 3 pH range is also where you find soda fountains. So most sodas are in the 3 pH, and it's very aggressive to metallic piping systems. So the model codes do require that special waste, as I just mentioned, be used to treat and neutralize aggressive effluents outside of what you would normally find in sanitary DWV services. And they point to those special piping systems again: CPVC, polypropylene, PVDF, and glass pipe as the piping systems that you have to have for special waste or chemical or acid waste applications. We're talking strictly for aggressive DWV applications right now. So the right material for the application, depending on what the application is either cast iron, DWV, or it's some special waste system. But I just want to make sure that we've got that clearly defined before we go forward. So for standard cast iron, it easily meets or exceeds the needs of the vast majority of DWV installations. And again, we've shown from the very beginning of this presentation that cast iron, as opposed to some other piping materials, has been around for a really, really long time. Again, 1562 was the first known installation, but there is evidence that a German cannon maker used his cannon molds to make cast iron pipe as early as 1455. So you're talking about 600, almost 600 years of manufacturing and use of cast iron pipe, and it's still going strong today. However, in certain aggressive environments, like what we've started to see over the last 10 or so years, the piping may need enhanced protection. And because of that, all of the domestic manufacturers, being those that are manufacturing cast iron in North America, are making an option using enhanced coatings. Also, a excuse me, an offshore producer has an epoxy equivalent that is also available. So this is coming in from several different providers because of the need and because of the aggressive environments that are out there. Some of those include undiluted cleaning chemicals. Again, I mentioned earlier, since the inception of COVID, hospitals have gotten very aggressive with their maintenance policies and how they clean the rooms and how they clean and sterilize equipment and things like that. And a lot of these cleaning chemicals are being sent straight down the drain without any wash down procedures and without any dilution. And also, in hospitals, there's a lot of other things that are happening there. If any of you are unfortunate enough to have been to a hospital recently, maybe to visit a loved one, you've probably noticed that healthcare professionals today will come into the room. They'll take a couple of pumps of hand sanitizer. They'll sanitize their hands. They'll deal with the patient. Then they take another couple of pumps of hand sanitizer, and then they're out the room. The reason that this is important is there's less and less water going into the drains in these healthcare facilities. So back in the day, your doctor or your nurse would come in, they'd wash their hands. There's always a sink in the room. They'd wash their hands, they would deal with the patient, they'd wash their hands, they'd leave. So there was lots of scouring that was taking place in here. But we've got low flow fixtures that are delivering less water. We have professionals who are using less water before and after they're treating patients. And then we've got healthcare maintenance personnel who are flushing undiluted cleaning chemicals down the drain without any washdown procedures. And of course, inside of hospitals, you have commercial kitchens as well. Commercial kitchens can be potentially hazardous to any type of piping systems for any variety of reasons. Of course, in commercial kitchens, you've got lots of fats, oils, and greases that inevitably are going down the drain. You've got very high temperature discharges from sanitation equipment or from pasta pots or things like that. So it's imperative that you choose the right material in these applications, and most of the time, cast iron would be the material of choice. What we have found is that very few folks are servicing their commercial kitchens in the way that they should be. And if you guys showed me somebody who was cleaning out their grease interceptor on a normal basis, it'd be the first one that I saw. So with those solids that are left behind, they off gas as well, and it's a real problem because it creates hydrogen sulfide gas. Hydrogen sulfide gas from the waste that is settling at the bottom of your piping. Now this waste is not injurious to cast iron. As a matter of fact, typically the pH is around 7.2, so well within standard cast iron's ability to work. But then it's covered up by the wastewater because these solids settle. They're not being cleaned out the way they're supposed to. The wastewater, along with the solids, create hydrogen sulfide gas. Now, mixed with oxygen, this creates sulfuric acid. And as you can imagine, sulfuric acid is very hazardous and corrosive, and it carries a pH range of about 2.85. Now, the condensing of that sulfuric acid can be extremely disruptive to any type of metallic pipe, including cast iron. And this is where we've seen some corrosion in healthcare and in commercial kitchens. If any of you have ever seen any degradation of cast iron pipe, it doesn't happen a lot. But when it does happen, it seems to manifest itself in this 12 o'clock region. And this is typically the culprit for that. So sewer gases are extremely hazardous to metallic piping when not vented properly, when solids are left behind off gas, when there's not a flushing system in place to make sure that the solids are not left behind. Casinos, resorts, hotels, all of these applications can be particularly aggressive applications because, again, cleaning chemicals, commercial kitchens, bar and soda fountains, folks are using facilities at all different times. There's not equal flushing going on. So we've seen some issues in some of these. And again, low flow fixtures contributes to that. While, a great idea and something that we must do to make sure that we're protecting the precious resource of water. It comes with some collateral damage, so to speak. And folks have been looking for quite some time now at sizing charts for drainage piping. We've brought down the flow characteristics in every way that we possibly can, but we still have these large diameter pipes carrying less water, and the scouring is not what it needs to be. So ICC 815, you've got anyway, several NIST is looking into it. There are several different competing groups who are trying to solve the problem of pipe sizing so that there's more water scouring the pipe. But again, while you're dumping things into the drain like sodas, fruit juices, alcohols, things like that at bar sinks and in commercial kitchens, there will always be aggressive applications for cast iron and other materials. And it's not just inside the pipe, it's also the hazards environmentally to the exterior of the pipe. So, one thing that makes Charlotte Pipe a little bit different from the others who are making these enhanced coatings is that we e coat both the inside diameter and the exterior, the outside diameter of the pipe. So, it's electrostatically charged ions. We charge positively the pipe and fittings, and we negatively charge the coatings so that they electrostatically adhere to the substrate, which gives a superior bond to both pipe and fittings. Because we know that there are applications that are environmentally hazardous to the exterior, not just the interior. You've got de-icing chemicals, you have salts, salt air can be potentially hazardous to any metallics, including cast iron. And so we want to make sure that the exterior of the pipe is coated as well as the interior. And here are some examples of what you might see with the buildup or scaling inside of cast iron pipe. And again, the same hazards exist externally. Hot soils is another one that some folks don't think about. And so the coating on the exterior of the pipe is equally as important. And so lots of times folks thinks, well, if cast iron is susceptible to degradation here, maybe we should use PVC, for example. And PVC is a great uh, option in a lot of applications. And again, I mentioned this when we started the presentation. We are a manufacturer of PVC pipe and fittings as well. So we know that PVC has its place, but you need to evaluate the entire application, not just what you think might be injurious to cast iron. So let's look at some of the reasons why cast iron, even standard cast iron, still might be the material of choice. Cast iron can handle temperatures up to 100 degrees Celsius, while PVC is limited to 60 degrees Celsius. And what's interesting to note there is that while 60 degrees Celsius is still hot and handles most things that are going to be dumped down the drains in terms of temperature, what happens to plastic pipe as the temperature increases? You may have noted as engineers over the years that the hanger spacing would decrease on PVC as the temperature increases. And that's a result of the tensile strength decreasing with exposure to hot temperatures. At the maximum working temperature, which is 60 degrees Celsius of PVC, it only contains 22% of its original strength. So this is important to note because the strength of PVC is adversely affected with the increase in temperature. And inside these aggressive applications, this is something that we've seen folks not really account for. Here, obviously, they did not use proper support spacing, but you see over time the system bending here, and this was receiving discharge from a steam kettle in a commercial kitchen. So another option might be CPVC. CPVC is commercially available. CSA B181.2 is the standard for PVC and CPVC DWV, and we know that at least one manufacturer is manufacturing CPVC for DWV that's commercially available in Canada. Now, CPVC has great chemical resistance to strong acids and bases. It is excellent with high temperature waste, being able to handle, I think, up to 104 Celsius, which is well above that of PVC and even above that of cast iron. Cast iron's limiting factor is the neoprene gaskets they use in the MJ couplings. However, most of the time, it's not normally listed or tested for DWV. And the reason for that is that while CPVC has great chemical resistance to strong acids and bases, it actually has very poor resistance to fats, oils, and greases. And fats, oils, and greases are something that you're going to see a lot of in commercial kitchen applications in particular. For that reason, as a manufacturer of CPVC ourselves at Charlotte Pipe, we do not recommend that you use CPVC in standard drain, waste, and vent because of fats, oils, and greases. They are stress cracking agents. They actually remove the chlorine from the CPVC and cause them to stress crack. So we wouldn't recommend our CPVC, and others have warnings listed on their websites as well. So um, so that brings us back again to enhanced coatings. And so there is a need, was a need. The industry acknowledged that. However, currently there are no CSA or ASTM standards for performance of epoxies and other enhanced coatings. Now, a task group was formed within ASTM in the subcommittee for the cast iron standard, and they have since developed what they're calling a guide. It currently contains some permissive language, so they're working to fix that so they can make it a standard. But there is an EN 87 standard. I'm sorry, EN 87 standard from Europe, excuse me, there, for pipe intended for sanitary DWV and storm drainage, and it is a performance standard for coatings. So we sought that out, and others are manufacturing their coatings or testing their coatings, I should say, to this specification. In it, you'll find things like 350-hour salt spray testing with 5% salt solutions resistant to wastewater, chemical resistant pHs from 2 to 12 for 30 days at elevated temperatures and low temperatures, and then resistance to hot water. So this is the most comprehensive test for coating performance coatings that we could find in the world, and we're currently ongoing testing to this standard with our coatings, and so are others. So some of the various enhanced coatings that are commercially available are urethane. You've got some resin-based coatings, some epoxies, some acrylics, and they can exist in many different forms, and in some instances can be blended. Here you'll see one manufacturer who is blending. They're using urethane on the exterior and epoxy on the interior. So it gives it a little bit different aggressive application resistance on the OD and the ID, but still it's great, particularly on the inside diameter. So there are various variations out there. The key that we found is the adhesion. So adhesion is very important, because here you'll see an example of one that was sprayed on that was able to delaminate when the chemical effluent got in between the coating and the substrate itself. So depending on what material the manufacturer is using to coat their pipe, sometimes the surface needs to be rough, others it needs to be smooth. So for us, ours needs to be smooth. Surface prep is key. It is, again, electrostatically adheres to the substrate, so there is no chance for delamination. Nothing can get in between the iron itself and the coating, and that is critical. And adhesion is the most important portion of the entire coating process. So, another thing that would cause delamination is augering. And of course, in these aggressive applications, augering takes place. Sometimes you have blockages. And if an auger removes the enhanced coating on some of these spray-ons, it can be detrimental to the piping system. So I would encourage you all to evaluate these enhanced coated products for what you think is right for your application. Now, for these epoxies, the fittings is a two-part fusion bond epoxy mixture that's sprayed on hanging parts and then baked. And then the pipe is sprayed on and air dried. Some of the epoxy paints, particularly from those offshore, are very high VOCs, which is a bit of an issue. So I would ask for MSDS sheets from the supplier just so you can evaluate those for VOCs and VOHAPs. And so for one importer in particular, they're making the fittings in China, the pipe in Germany, sometimes in India, and I'd just be on the lookout for that. So for the electrocoating applications, again, a lot different than the spray-ons. The pipe and fittings are electrically charged, oppositely charged coatings. The particles are introduced, and then it's a molecular integration of the coatings to the substrate. So there's no chance for delamination or chipping or anything like that. It's evenly coated in even the hardest to reach areas. So great uniform coating. You've seen photos in each one of these slides from various manufacturers. And again, there are multiple manufacturers who are making these enhanced coatings. From Charlotte, ours is called Edge HP, and HP is for high performance. Now, oftentimes I'm asked about cutting and installation. There are no special MJ couplings that are required for these. The neoprene gaskets are perfectly fine to be used with these coated cast iron systems. And in terms of cutting, for our product, you use the same snap cutters that you use for standard iron for large diameters. An abrasive chop saw makes the best possible cuts. These snap cutters have been around for a really, really long time. They make good cuts, and they're the most efficient tool for cutting cast iron. And then so folks will sometimes ask, what about treating the ends after it's cut? Well, different manufacturers have different recommendations. So check with the manufacturer for the field cut ends. For our system in particular, because of the coating, it is not required that you treat the ends because again, the effluents cannot get in between the coating and the substrate. For some of the others, the way that their coatings are applied, they would like for you to put some of their coating. They'll send it to you and put it on the cut ends, tape it up before you put the couplings on. So again, just depends on the manufacturer and their recommendations. So sorry, I already covered this about the VOCs with the offshore guys, but all of those made in North America are low VOCs or low volatile organic chemical coatings. Sorry, and again, they meet the standard for VOHAPs as well. Now, I know I sped up there at the end, but I saw that I was getting short on time. I wanted to leave some time for questions, if any of you have those, and then also for Zach to sort of go through the ATS system. So I'm going to stop sharing my screen now and turn it back over to Zach.
Thank you. Yeah, I think for me, the number one question that always comes up anytime we're doing this presentation is just, I guess, like a re-summarization of like the key applications where they should be thinking about these enhanced coatings. And correct me where I'm wrong or if I'm missing anything. Healthcare, commercial kitchens, and kind of any ultra low flow applications where we're having a higher concentration of, we'll say, solids and excrement or whatever you want to call it.
Yeah, that's right. Also, parking garages on the anywhere on the coast where you've got high salt air content is another great place to use that. And one thing that I should have mentioned, Zach, that I haven't mentioned yet, is that this piping system can be combined with standard cast iron. So if you expect some problems in a commercial kitchen, then that's the only place you should put this enhanced coated cast iron. Use standard iron throughout the rest of the application, and maybe you only need 10 or 20 or 30 feet of it in a particularly aggressive spot where you've got a commercial kitchen that's got some aggressive cleaning chemicals, or at a bar sink or something like that. So we wouldn't suggest that you use this throughout your entire hospital or an entire building, but only where you expect some problems.
Like maybe say in the healthcare, it might be the dialysis ward, or
Perfect,
for an
perfect application.
ultra low flow, like a lead office building, maybe just from your behind the fixtures to the stack.
Exactly.
It doesn't necessarily need to be the entire facility.
You're exactly right. As a matter of fact, we wouldn't recommend that you use it for the entire facility. There is a premium to these products. They will cost about 25% more than standard MJ pipe and fittings. You don't need it in 95% of the applications, so there's no reason to use it. You would use it in conjunction with standard iron only in the areas that are hazardous.
Perfect. Well, I don't see any other questions coming in, so I'll jump over to screen share here, and we'll kind of walk through the spec tool and how people might be able to find this and incorporate this into their product selections. And again, for anyone that this is your first time seeing us, thanks for joining our ATS University session. This is put on by the ATS Spec Tool team. ATS Spec is, in essence, a house of brands. We have about 45, 50 different manufacturers that are available on the system. Allows you to configure your actual selection and not just look for, say, a base model. But we do also specialize in integrating base models and detailed specs into your internal masters. The goal is always to provide an updated system that ties into your internal processes. We're not looking to replace how you're doing your product selections in your projects right now. We're looking to tie into how you are doing those selections. One thing we're asked all the time is how we might come back to this information that we covered today. In the Architects and Engineers tab, before you even log in, you can go into the Learning Hub and our webinar recordings. We also have our ATS knowledge base, which is essentially a blog that covers a variety of topics from how to size your grease interceptor to, design guides in the future on, these coatings would probably live there. I mentioned the login. Again, everything is a free software for the designers. It's paid for in essence by the manufacturers that support our tool. But you do have an individual login with your work account tied to your firm. You can share projects, share masters across your firm. And we have some firms that have multiple offices all across Canada or all across the US, and allows you to set a standard that then distributes down to, every EIT, every junior, every designer making selections can be confident that they're working off of your national approved standard. That's our goal. Once you're logged in, you can see my account here, the Demo Engine account. So I'm sharing projects with everyone within our Demo Engine account. Got our dashboard here, tells us a little bit about our usage. Try to focus on a couple of products. And then you've got your sidebar here where you can access any of your previously created projects, masters, and quick specs. You can access the product catalog right away through this button on the left, and that'll pull up our tile search. I'm going to jump back to the dashboard for very quickly and just cover that quick spec projects and masters again. So your quick action bar here is how you will kind of get started with essentially creating a folder. And these folders have different levels of permissions and rules to them. A quick spec is just as it sounds. It's the fastest, most rapid way to make a selection, but there's no location-based rules. There's no building code rules. None of that is applied. Those are applied to projects because when we create a project, I'll show you this real quick. Quick spec, we could say pipe, and we can go into our category selection. It's going to bring up those tiles. I can find the pipe category and I can filter down by application rating, fire rating, anything like that. Find my cast iron no hub and add product to the selection. I can also find that edge HP aggressive waste areas that we were talking about, and I could simply hit add product and it'll add that in to my quick spec. If there's any other, accessories, additional equipment that should be selected with this, it pops up along the way. So we've got our, T's, Y's, and crosses, the additional products that might be needed. So we can add that in. You can see it calls up the hangers and supports, couplings, even pipe identification here. Everything that's required in what we call the fixture chain. So we can put a loop in, or I can bypass any of this and just hit complete. And that's true for everything across the system. So that's a simple quick spec. A project is where we add location information, application information, and bid date. So the location lets us determine which local building code and make sure that the products are applied to that local building code. So when this comes to things beyond pipe and we're talking fixtures, it'll apply the barrier-free rule engine for Ontario or for BC or for Alberta and make sure that your projects are meeting those. The bid date is how we keep your projects and masters up to date. Quick specs do not get notification updates. Projects up until this bid date. So if we select October 10th, up until October 10th, you will receive notifications. Hey, this product's been discontinued, or hey, this model number has been adjusted, or hey, there's a change to this key product feature. And you might want to log in and either make a new selection, re-download your spec, or you might even get an invite from me to meet and discuss so we can help you make the appropriate selection in the case that there's not a clear alternative. And then our application allows us to make recommendations by application. For example, with the recent NRCan 18 update, healthcare has a different flow rate requirement than your general office buildings, which is different than your residential facilities. So all that information is tied into the application that you select when you're building a project. And then the master is similar to a project. We provide the updates and you can select these by application, but it is in essence your repeat work. So if you are doing either your national or your firm-based standard, these are the products that we approve. These are the appropriate toilets and lavs, right down to water heaters, backflow, pipe, and accessories. You might approve, copper or cast iron or stainless. You can set those in your masters. And then instead of going through that, individual selection, you can see I've got a webinar hospital project here that I created. We got no product in here right now. We can use our masters and templates, and you would have your firm's masters here. You would have our ATS templates here, and then any of your favorite products. So it's the same functionality regardless. So I'll show you how we can very quickly build out. Let's do, say, a long-term care project. We need a general use and a barrier-free selection. So I'm going to grab a toilet and a lav. Maybe I need a wall hung option. And every time I check the box and grab the dots, you can see it says 3 products. Those are going to copy in. And then I could go in and get my barrier-free selections as well. I'll do a barrier-free and grab the dots, and it'll drop off into the sidebar. And then if I want to, after I've gone through all my fixtures and my equipment, I can go into my pipe section and go to our ATS Canada Pipe Master spec or your approved products as well. Maybe we've got, distribution piping and for distribution, we've got our general waste and our aggressive waste piping. We go through and grab our identification, hangers and supports, and even the couplings. We've got our heavy duty coupling and no hub coupling. Maybe for the long-term care project, our firm has a standard where we only include heavy duty and we just drag and drop those products into our package. In a matter of seconds, we're done. We know exactly what we selected. It's all from the approved standards that my firm has set. And then I can go and hit the download button. Hide that. So once I check the boxes, any of the boxes that are checked are going to be downloaded. So you can see it says one, two selected, or select all. And I'll hit download. And then I can download it in submittal, long spec, short spec, CSI 3-part spec, Revit files, manufacturer spec sheets, and even product brochures. Although, to be honest, product brochure probably doesn't get used very often for pipes and fittings. This is mostly used when you're trying to present, larger images, just the key details for, say, fixtures. Maybe you're comparing a couple of faucets. That's mostly when that comes in. Hit generate documents and it'll put together a nice zip file for you, which I've pre-downloaded here. So written spec comes out looking like this. Every one of our formats is open and editable. And then this could be copied and pasted either directly into your drawings, into your schedule. You can put this into your internal written specs, your book spec, however you're issuing your project to market. And then we get the manufacturer cut sheet version, which looks like this. Nice clear title page, table of contents, and then the manufacturer spec sheets on the system. And then if we're looking at our submittal documents, slightly different. This is a lot of the same information, just relayed in a different format. So our submittal format here shows again exactly what's been selected. Nice clear description, nice verbiage that you can put directly into your internal submissions. We have a lot of people that might um, issue their books back, but it's handy to have these images, these submittal documents to look at, especially for review. There's some firms out there that might put these directly on their drawings or keep in their internal standards so that it's easy to come back to down the line when maybe you're reviewing a change notice or you're reviewing comparing to shop drawings, and you get a nice zip folder just like this that has all the various info. So I don't have Revit on my machine, but you have the Revit files there as well, if need be. So yeah, that's the quick overview of the spec tool. If you would like to look at your company's internal standards and masters and see how we can build them onto the spec tool for you. If you'd like to review your current pipe spec and make sure that it's calling out all the appropriate standards and including all the appropriate manufacturers, we're happy to join you and assist in that as well. If you would like to get a presentation like this, maybe a deep dive, if you have specific applications you're interested in, we're happy to set that up with our partners at Charlotte. We can do an aggressive waste presentation specifically for your firm, or we can review that section with you to make sure you're calling out all the appropriate standards. And if you have any questions along the way, please feel free to reach out. Zach at atspec.com is myself. We'll have Brian copied. If any of the questions come up, we'll have the list sent over to Brian shortly so that he can send out your ASPE accredited certificates, and our team will have our ATS certificates of attendance out by the end of the week. Thank you very much for all your time today. Hopefully you learned something. I know I always do. I didn't know that fun fact about the Smithsonian. That was a new one for me.
Nice,
I'd
nice,
seen the Palace of Versailles stuff before, but I hadn't seen the Smithsonian one, so that was good.
very good.
Thank you all for your
Thanks,
time. Have a great rest of the day.
thanks, Zach.
Bye for
Thank
now.
everybody. Bye bye.